All right, let's dive in. Today, we're tackling one of the absolute cornerstones of Java, inheritance. Think of it like building a family tree for your code. It's all about making what you write smarter, cleaner, and a whole lot more organized. Let's get to it. So let me ask you something. Does this sound familiar? You write a great piece of code. Then you need something kind of similar, so you copy it, you paste it, you tweak it a bit, and then you do it again and again. Suddenly, you've got the same logic in 5 different places, and when you find a bug in one, you have to go on a scavenger hunt to fix them all. Yeah, we've all been there. Inheritance is the beautiful, elegant way out of that mess. So what is this magic bullet? Well, at its core, inheritance is just about creating a family of classes. You start with a general, or parent class, and then you create more specific child classes that automatically get all the features and behaviors from the parent. To put a more formal pin in it, inheritance is the process where one class, we call it the child or the subclass, inherits the fields and methods from another class, the parent or superclass. The child class basically gets a massive head start right out of the gate because it doesn't have to start from scratch. And how do you actually do this in your code? It's surprisingly simple. It all comes down to one little keyword, extends. When you write class child extends parent, you're making a formal declaration to Java. You're saying, hey, this child class, it's part of the parent's family. It gets all the family heirlooms, all the public and protected stuff. That's it. The connection is made. So why on earth would we do this? Well, the benefits are huge. First, code reusability. This is the big one. Write it once in the parent, use it everywhere in the children. No more copy-paste nightmare. Second, it just makes your code easier to read. It creates a natural, logical structure. And third, maintenance becomes a breeze. You find a bug in the parent's code, you fix it once, and poof, all the children are instantly fixed. And that last point, polymorphism? Ooh, that's the secret superpower this all leads up to. We'll get there. Now, it turns out that not all class families are structured the same way. Kind of like real families, right? Let's take a quick look at the different inheritance patterns that Java supports. You've got 3 main types. First, single inheritance. Super simple. One parent, one child. Then you have multi-level inheritance. Think of this like a direct line of succession. A grandparent class, a parent class, and then a child class. And finally, you have hierarchical. This is like siblings. You have one parent class, but multiple different child classes inherit from it. But you know, there's one particular family structure that you might think is possible, but Java deliberately says, nope, not doing that. And it has a really good reason. And this is it. In Java, a class can't have 2 parents. It can't extend 2 classes at the same time. If you try, you'll get an error. This concept is called multiple inheritance. And in Java, it's a no-get. So why not? What's the big deal? It all comes down to one word, ambiguity. Imagine a child has 2 parents, parent A and parent B. And let's say both parents have a method called do something. Now, if the child calls that method, which version should it use? Parent A's or parent B's? It's impossible to know. It's confusing. So Java just sidesteps the whole problem by saying one child, one direct parent. End of story. It keeps things clear and predictable. Okay, so we've set up this family of classes. How do they actually talk to each other or even refer to themselves? Well, Java gives us 2 incredibly useful keywords for exactly this purpose. This and super. Honestly, this is the easiest way to remember it. The this keyword is like an object pointing to itself and saying, me. It refers to the current instance of the class. The super keyword, on the other hand, is the child pointing up the family tree and saying, my parent. It refers to the immediate parent class. It's just me versus my parent. That's the core difference. Here's the most common place you'll see this. Take a look at this constructor. The method receives parameters named name and age, but the class also has fields called name and age. So how does Java know which is which? We use this.name to be crystal clear. We're talking about this object's field, and we're assigning the value from the name parameter to it. It's all about getting rid of any confusion inside the class itself. And super, well, super is the child's direct line to its parent. Let's say a child class redefines a method, but for some reason, it needs to call the parent's original version of that method. That's what super is for. It lets you reach up and access the parent's methods, its variables, or even its constructor. It's how a child can say, hey, I need some of that original logic from my parent. This brings us to a really fun idea. What if a child inherits a behavior, a method, from its parent,
but it wants to do that behavior in its own special way. This is like a child growing up and developing its own personality. In Java, this is called method overriding. So what's happening here? Method overriding is when a child class basically says, hey, thanks for that method, parent, but I've got my own way of doing things. It provides a brand new, specific implementation for a method that it already inherited.
Now, you can't just go wild with this. There are some rules. The method name and its parameters have to be an exact match to the parents. The return type also has to be compatible. And here's a big one. You cannot make an overridden method more restrictive. So if the method in the parent is public, the child's version can't suddenly become private. That's just not allowed.
And now we get to the grand finale. All of this stuff, inheritance, super, overriding, it's all been setting the stage for one of the most powerful and elegant ideas in programming. This is the ultimate payoff. This is polymorphism. The secret sauce that makes polymorphism work is something called dynamic method dispatch. Now that sounds super technical, but the idea is actually pretty simple. It just means that when your code calls an overwritten method, Java doesn't decide which version to run when you compile it. It waits. It waits until the program is actually running at runtime, and only then does it figure out which method to call. It's this wait-and-see approach that makes all the magic possible. And this right here is where it all comes together. Look at this code. We create a variable with the type parent, but the object we actually assign to it is a new child. Now, this is perfectly legal because a child is a type of parent. So when we call the show method on that variable, which one runs? The parent's version? Nope. Java looks at the actual object at runtime, sees it's a child, and runs the child's overridden method. This is it. This is how one object can take on many forms. So that's the real power here. Inheritance and polymorphism give you the ability to write incredibly flexible code, where an object can be treated like its parent but always act like its true self. The word polymorphism literally means many forms. So the only question left for you is, now that you know how to make your objects take on many forms, what are you going to build?